going to say hello real quick and thank you to all of our ham radio TV viewers on behalf of the Vacaville Radio Club. Thanks for watching our channel. We really appreciate it, and we hope you enjoy it and continue to do it. Tonight, we're going to talk about coax and some practical applications for it, so you'll be able to take this information, go home, and apply it to your station. We're going to talk about the different types of coax, the loss in the coax, and why you might choose one over the other. And we're going to give you two formulas that aren't very difficult, though you'll be able to go home and look at the chart and use your calculator on your phone or your little $7 or $8 calculator that you can get from Target, and it will give you the answer. Another thing we want to do is I want to address three questions real quick. We're not going to go into them in great detail, but several club members, and we've had three or four or five inquiries from the ham radio TV about velocity factor of cable, about the common mode rejection on your coax, or what's coming down your coax from your antenna, and the other one was, why should I do that? Okay, so we're going to address the velocity factor of the cable. We're not going to get into gory detail, but we're going to do another video on that. But the velocity factor of the cable is on these charts. We'll reference it later. You look that up, and that helps you determine the length of your cable or the length of your dipole antenna, depending on what you're doing and what formulas you're using. So the velocity factor of a cable matters. The reason somebody asked, why would we care about our coax? Because your coax is your transmission line that gets the energy from your radio to your antenna. In this case, our fake antenna, this guy right here, the dummy load, the bird dummy load with a wattmeter in it. If you can't get all the energy from your radio to the antenna, and there's losses in between, it's going to degrade your signal on the transmit and the receive. It's not one way, it's two ways. So that leads us into the question, why would I care about the length? On HF antennas, most of the time, we're trying to get optimum performance out of our antenna. So if we had a perfect antenna, let's just pretend that it is, and I get the wrong length of coax. Let's say I'm using a 37-foot piece on 80 meters. I'm probably never going to get that antenna adjusted to where it's matched at 1-to-1 SWR. It's perfect because my cable's too short. Okay, but if I extend that cable to where it's closer to a half wavelength multiple, then magically my coax, it looks at the antenna impedance and reflects it back to the transmitter. So if my antenna impedance at that frequency is X, it'll reflect X back here. But it's only at the frequency that you cut the cable, and there's a bandwidth that you can use it within. And we're going to do another video. We're not going to spend a lot of time. We're not going to spend any time on that tonight. So I'm hoping I answered the question that it's one more way of using your coax to benefit your transmission and your reception to the best of your ability. And the last but not least, somebody asked, what's all this have to do with the common mode or the energy coming down the coax? Well, that's from an imbalance up on your antenna. It's from your energy is going up, and then something magic happens up there, and it comes back down on the shield. So that can happen on any length of coax, and it matters whether it's if your antenna is tuned right, if your coax is the right length, but the 1-to-1 current balance is what we were using to alleviate that problem. So we'll do another video on that, and we'll have some equipment tests set up to show you what happens when it's working, when it's not working, and we'll set up a spectrum analyzer and show you what common mode looks like, how many dB down it is, and we'll show you. But we're not going to do that tonight. That's a whole nother presentation. So tonight we're going to talk about coax. So some of the really familiar stuff, you know, is generic terms. We got RG8, we got RG8X, we got RG58, you know, and then you hear the term, well, I went out and bought LMR 400. They're all different cables, and they all respond differently. So what we want out of our transmission line is, what's the number one thing we want it to do? Transmit. Yeah, we want to get the energy from our radio to the antenna. And what's the other thing we want to do? Get it back. I'm going to get the energy from the antenna back to the radio. So what I've got here, and we're going to do some little experiments. This is just an old leftover piece of RG8X that I had laying around. I think I got this at a garage sale for like $3 or $4. Okay, took it home, swept it. It happened to be okay. I won that time. This is a real popular item off of here. We'll put it down here too. This is just some RG8X, RG Mini 8. It's the small stuff, okay? And I bought this one off of Amazon. So if we take a look at our charts, guys, both of those charts have RG8X, right? And you ask yourself, what is going to happen when I put my signal into this? And tonight, we're going to, on purpose, we're going to use 2 meters and 440, okay? Because I think all of us use a 2 meter radio, and most of us use a 440 radio. So, and that's really common. We get questions all the time. Hey, I just bought my new Yaesu or ICOM radio, and I'm using my HT. I got the adapters. I want to put an antenna out. What cable can I use? And I can honestly say 50% of the time, this is what we see. People buy it because it's cost effective. It fits through the window. It's flexible. So let's look down here on the chart, guys. So we operate our ham radios in the 400 megahertz range, right? And notice this one chart. It shows 400 megahertz, and you go to RG8 at 100 feet. Okay, at 400, what's the loss? So you go on the left-hand column, look down, and you'll see 400 megahertz, okay? Because that's close to our ham band. Then you slide your finger over to the right, and you stop where the top column says RG8X, okay? What's that number? 7.9 dB, right? Yeah. So that's per 100 feet, right? So you can take that number and you could take your $8 calculator from wherever, and you can take 7.9 and divide that by 100, and you get 0.079. So what if I have 50 feet? What do? Multiply it times 50. And that will get me close. So now I'm at 3.95 is my calculated at 400 megahertz. Now I'm going to intentionally have you look at, on the same sheet, look down there and find 450 megahertz, okay? Right at the top edge of the ham band. Go over and find 8.6. Yep. 8.6. It went up almost 1 dB of loss per 100 feet in 50 megahertz. So length matters. So I often get asked, well, what does that really mean to me? Well, we're going to do that right now, and we're going to do some cables, and we're going to look at the chart. You guys I'll tell you what cable we're doing. I'll tell you how long it is. You could look at your chart, and you can pretty quickly estimate what the loss is going to be. And we're going to do it looking at that Wattmetter, and we're going to do it with a dumb old 30-year-old Alinco radio. And the experiment is set up as follows. You put a power into it. You note what that power is. I'm going to ask somebody to write that down, okay? We're all going to look at the meter. We're going to say, what's the power going into it? And then we're going to unplug it from our test unit, and we're going to insert this cable. And what's happening is the test unit from the output port of the radio, that little flexible coax in the back of your radio, I have a double male connector, which emulates the double male connectors here with no wire between it, okay? So the loss is virtually, for our experiment, is virtually zero. So we're going to take that connector out, and then we're going to push the button again and read, and we're going to read the reading, and we're going to know how much power. And then we'll be able to use our chart and our phone or our calculator or whatever, and just in about 38 seconds, we'll be able to prove whether these charts are right and what this cable's really doing. And then we can talk a little bit about what's going on at the end of that cable with a particular antenna that I purchased. So let's do this. Who wants to be my technical secretary and write things down, Dean? Oh, thank you. I appreciate that. So we are going to use our test standard tonight. We're going to use, because it's programmed in my radio and there's nothing special about it, is on the 2 meter band, we're going to use, let's write this down. Our standard will be 147 megs, okay? 147 for 2 meters. And on 440, we're going to use 446.0, okay? This is our first measurement. All I'm going to do is key the radio, and I'll have you guys read it. So we're starting with 2 meters to 147. How much power is that? It's on the 50 watt scale. 41. It's 41 dot, it's 42. Exactly. 42. Now, just to be clear for you guys and for anybody watching, this is our amateur radio gear. And what we're going to do is we're going to find out how close are my 30-year-old radio and my kind of calibrated meter that I've swept frequency-wise. The thing is beautiful to 600 megahertz. But as far as looking at that watt meter and knowing that that watt meter is within X number percent, I don't know. It's close. Okay? So we now know what it is for 147 megs, right? So now for our test, now I'm on 446 megs, and on the average dual band radio, what's going to happen? Got to drop. Exactly. So what's that? 28 watts. So for our test procedure, 2 meters is 42 and 440 is 28. So let's just keep it formal. We'll start with the 47. So 147 megahertz, I'll lean over here and I'll take out the little adapter off the port, and I'll try to hurry this up. I hope this is reasonably interesting because it's useful, and we're going to give you guys a quick formula here in a minute that you'll be able to do this without a meter at home with your calculator to get close. But first we're going to find out how close is close. What's the cable? This cable is the Amazon RG8X. And in some of the listings they call it RG8 Mini. And I'm reasonably certain they're talking about the same thing. When I bought this, it was RG8X. It's 50, oh, by the way, it's 50 feet. It's 50 feet. So we're testing RG8X at 147 megahertz, 50 feet. What's that?
25, roughly 20 feet.
Yeah, 25. That's really good. Okay, so look at the chart and tell me what you think 50 feet should be for its loss before we calculate it. 25 watts is the output. We put 42 into it, right? And then we keyed the radio and we got 25 out. So the cable ate up that power. It's gone. Let's go down to the other chart and go to the 150. Let's get the frequency as close as we can. The charts don't give us everything.
4.7.
So we're looking at, okay.
Yeah, but it's 50 feet.
It's
half of that.
So it's 4.7 for 100 feet, right? So I'm going to go the long route. I'm going to go divided by 100. And now I'm going to go times 50 because that's how much I'm using. So I came out with 2.35, right? So when we figure this out, we're probably going to be close to 2.35 dB. Here's this is in the ham radio handbook. It's even on some of the test, but not the technician test or the general. I think it's the advanced. The formula to do it. Did anybody know what it is?
It's a log formula.
It's super easy. It's 10 log, the power out over the power in. So what you guys do, I'll have to go over here because I don't have I'm sorry, I'm walking out of frame, but that's just what I do. So we're going to go 10, take the log, and we're going to take the power out, I can't write, over the power in, okay? So in this case, what's our power out, guys? 25? 25. Okay. And what was our reference power in? 42. Okay. So now here's where, I'll get out of the way, dude. So here's where you could take your $8 calculator. You can also use your cell phone. You pull your cell phone out, and you can use the scientific calculator. That's a super basic formula, except for the part that the instructor can't write. So what we're going to do is we're going to take our power out, which is 25, and we're going to divide it by our power in, which is 42, right? And we get a number. And then you find the button on here that says log, and just push it. Right? And now, times 10, because we're talking about power, okay? Times 10. I came up with 2.25. What did we estimate it at? 2.35? I'd say 0.1 is pretty dang close. So we used our calculator and a formula that's been around for, I don't know, forever, as far as I'm concerned, and we figured out what it was. So now, that's a 2-meter radio, and I put my 2-meter radio, and I got what was it? Did you write the number down? 2.2, 2.3 dB? Okay. So we lost 2.2 dB. What does that really mean? Well, it really means my radio put out 42 watts, and my antenna that's resonant at that frequency is only getting 25 watts. You're 2.5, almost 2.5 dB down, right? And then you go, well, I built my my ground plane that looks like Sputnik, right? Which has no gain, basically. It's basically a unity gain antenna. And you plugged it in. Well, what's getting to that antenna? About 25 watts. The cable ate up the power. It just dissipated in heat. It's gone. It's not going to freeze. That's right. That's right. It's not going to freeze. So that's one piece. Now, what do you think is going to happen? I'm the guy, 50 foot's not long enough. I need 100 feet, right? So I'm going to take my little cable tester here, and I'm going to unscrew this puppy, and I'm going to screw my other piece of RG8X, which is what gets purchased a lot. And by the way, RG8X, there's another number for it. It's more expensive. It's a better cable. And I think it's called LMR 240. And that stuff's expensive. But you look on the chart, you'll see that the loss on that is not much better than this. So we have our reference. And all I'm going to do is push the button on the radio. Oh, look at that. Yeah, 13. Each of the lines past the 10 is 2 watts. So it's about 13. Yeah. So we'll do the same thing again. We'll go 13 divided by our 28. Excuse me, it's 42. It's about 5, right? So it's about 5 it's about 5 dB down. What's the chart say it's going to be? 4.7? Man, I would say we're pretty close considering that we used old cable that I got at a garage sale, and I have a barrel connector and the brand new cable. But the bottom line is we were at 5 dB, right? Of measured, and the chart said 4.7? 4.7. We're within 4.3 dB of what the chart says in the real world. So what does that tell you? You can use the chart off the internet in your calculator, and you can figure out, for yourself what the power is going to be. Let's say we're going to buy 50 feet of that cable. I look RG8X up, and it tells me that I have 4.7 dB of loss per 100 feet, and I want to purchase exactly 100 feet, okay? We'll make it easy. And my radio is 100 watts, and I'm going to use that, and at the frequency I want to use it at, it's 4.7 dB of loss, right? And I'm making this up. I don't know. I'm not picking I'm just saying the chart says that 100-foot piece of cable at the frequency that I want to use has 4.7 dB loss, and I got 100 watts. well, man, how much power is going to be in my antenna? Do I need to have a gain antenna? Should I buy better cable? You can figure that out too. You could take the loss, that number, and you can put that 4.7 and you make it a negative because it's a loss, okay? And you divide that by 10. And then you're going to hit the opposite of the log button, you hit your function, hit the opposite of that log button, and then you'll multiply it times 10. Or excuse me, I screwed up. We're supposed to multiply it times 100. That'll work. So I'm going to get about 34 watts, 34.2 something at the end. So you can look at the chart, and you can use the formula backwards so that you can get, what your power is going to be. And at UHF and VHF frequencies, it's way more critical. Because look at the chart, guys. What happens when I take RG8X and I use it at 10 megahertz or below? It's less than 1 dB loss per 100 feet. So at that point, I'm just worried about my length, half wavelength. I'm worried about, or concerned. I'm not worried. I'm concerned about the power handling, all that kind of stuff, And if it's a quality cable that's UV resistant, all the normal stuff that we do. But if I'm going to only use it on the HF bands and I don't go past 10 megahertz, I go, man, that's like 1 dB. I can handle that. So you could take that 1 dB, and I'll just do it really quick. And we'll look at that, and we'll see. So on that cable, I lost 1 dB at 100 watts, right? It's about 79.4 gets to my antenna. You lose about 20 watts in that 100 feet of cable at 1 dB. Because when you're measuring things, I use dB as a reference. 3 dB is half. So if I have 100 watts and my cable has a 3 dB loss, I got 50 watts at the end. If I got a 6 dB loss, I got 25 watts at the end. Cuts it in half again. So it matters at the VHF and UHF frequencies. So these charts are super duper handy. So we did the most common cable just for fun. And we picked our 2 meter frequencies because that's what we use in our 440. Let's disconnect this cheap coax. Or let's use the word cost-effective coax because it has its place. I didn't even bring RG58 because, in my opinion, that stuff is so lossy for home and base station use. It's just for lower frequencies and or higher frequency. By the way, there's 800 meg trunking systems and other stuff. And most of our magnetic mount antennas that we buy, depending on what you've purchased, are going to be typically they're going to be a RG58 or RG8X anyways, because it's your mobile. And if you look at it, they're usually 17 feet long or something. This is a 100-foot piece of RG214. So look at that chart. See what your RG214 looks like. 214 is double shielded, 213 is not double shielded. And they're very, very, very similar. And I don't know the gory details except one's double shielded and one isn't. And they're both when you buy it by the foot, they think it's made out of gold. That's why all my cables are old and I take care of them. Because I don't want to buy more. So there we are. We have our RG214 in there, and we're at 147 megahertz, and we put 100 feet of cable in. Oh, look at that. 20, I'd say 23. It's just right, it's close. We'll call it. Okay, let's call it 24. So there you go. So now we know 213, 214, 100 feet of 214 is better than 50 feet of RG8X, loss-wise. And keep in mind, that's a two-way street, guys. You're losing your power going out, and you're bringing your receive down coming back. So it's a two-way street.
That's more important
and you receive. Yeah, if you can't hear people, what's the point, right? What's the point? So with that said, we'll take this apart, and I've got another piece here. Oh, by the way, let's do this. We did 440 on the other one. We lost a ton, didn't we? Let's go to 440. So our reference number on 440, the first measurement we took was what? 28. Look at that.
10.
It's 10. See right there? We're 28, we're 10 watts going through that gray piece of cable. So we're still using the same 214 cable. We just went from 147 megahertz to 446 megahertz. And man, the loss just went off, well, it didn't go off the chart, but it's significantly more. So we're at 10 watts. We'll divide it by the 28 watts, our reference, and we'll take the log of that times 10. So this guy, I'm coming out about 4.47, something like about twice what it was on 2 meters. So what's the chart say on 213 at 450? It says 5.2. So we're 4 or 5 megahertz lower, and our numbers came out 4.5. So we're within a half a dB. That could be the frequency, it could be my connectors, it could be a bunch of things. But we're actually pretty close. So let's do this now. I happen to have, we'll do 2 more quick cables, and then we can answer some more questions. And we'll do this one at 2 meters. And 213 is an actual really popular cable, guys. Super duper popular. I'm going to dump these out of my way, because we're not going to use this for too much. We're going to use our 213 and 214 and so on and so forth. I'm going to tell you guys straight up, this is a trick question in a sense that I know what's going on with this and you don't. This is, look at your chart. This is 80 feet of RG8U foam. 80 feet of RG8U foam. So we're going to check it on 2 meters first. So I want you guys to give an estimate of what you think it's going to be. We're going to do 80 feet at our 147 megacycles, and we know what our reference is 42, and now there we got about 23. 23. So you guys tell me what you think the loss should be. 1.6? Yeah, that's right. That's really, really, really close. But that's not what it is. That's why I'm doing this. So you guys see the difference. So your numbers came out about approximately 1.6. It actually lost 2.6 dB. Well, when you use the formula, it's less loss. When you look at the chart, it's less loss. But when you look at that and you use a formula, it's 2.6. And the reason is that's not a good piece of coax. It's far enough off that it's goofy. Now, let's do 440. Yeah, wait till you see this. So we know our reference is 28 watts, right? Okay? What? Yeah.
1, 2, 3.
Yeah, it's like 5 or... Yeah, we're at 10, 8, 6, 4, even if it's 5. So we'll say, is it 4? Okay. So 4 divided by our 28 reference, right? Take the log of that.
8.45.
Yeah.
Got a space heater.
Yeah. It's 8.4 dB loss at that frequency. Matter of fact, you could get a new piece of 213 running 100 feet, and it's not that much. Yeah, this is not a good piece of coax. It's just not. So there's another reason you can use your radio and your wattmeter with a dummy load, and you can approximate, based on the charts and a little bit of math. Is my cable any good? Or you can go buy a MFJ or a rig expert and a dummy load, and you can do it that way too. But not everybody has that. So if you want to play around with your coax and understand, you could do it with just and you don't need that watt meter. You could just get a diamond watt meter or MFJ watt meter and screw one of the dummy loads right into the back of it and use that to get some approximations. Now, this is on the chart. Not quite. This is kind of like LMR 400, but it's not, because my friend bought me a 100-foot piece of LMR 400 and he forgot it. Anyways, he's going to give it to me too. Not really, I'm lying. This is a piece of RG11. Look at the loss on RG11, guys.
75 ohms, isn't
It is 75 ohms, but I'm just talking about loss right now. I kind of don't care about the 75 ohm thing, and you're going to be surprised. This is approximately, the approximation I give you is 100 feet, but I think it's 103 feet. Because this is a scrap that was getting thrown away. And I grabbed it. He was a friend. Yeah, they were throwing away a bunch of junk. And they go, we can't use that. Okay, so let's start off at 147, okay? In our 147 megahertz. We're still at we're only using 147 megahertz for 2 meters and 446 to measure for 440 to see the difference. So here we are on 147. Look at that. Yeah, about 23. Now if we flip over to the higher frequency, see what's going to happen. It's still handled. So let's do this. So we're about 13 watts on 440. And we're about 24 watts, give or take a little bit, on 2 meters. 13 and 24, right? It's about 103 feet. So let's look and see what it is over here. We could do another experiment with this stuff, but we don't do it tonight. You could put an SWR meter in there behind your radio and see what it's doing, because it's going to have some reflected power because it's the wrong coax. We're on. So 24? Yeah, almost the same.
100 feet?
100 feet. That's the other stuff's actually a little bit longer. Yeah, it's about 100 and somewhere between 103 and 110. I wanted 116, but they couldn't get a scrap that was that long. So there's what it looks like. And then you go to your 440, and there you go. It's almost the same. So if we had a piece of LMR 400, we'd check it. But I think the point of all this is all the coaxes are different, right? There's a different application for each coax. So if we're going to a lower frequency and we want to use RG8X below 10 megahertz, go ahead. As long as you're operating under 1,000 watts, you're fine. You want to operate a little higher in frequency, and you're a little more efficient, go buy a good piece of RG8, something with less loss. You want to take your brand new Yaesu Fusion HT, plug it into your base antenna, use it on 2 meters or 440. You better think about how long that wire is, because the thing only puts out somewhere between 2 and 5 watts, right?
5 watts.
5 watts. So if you only have 5 watts and you lost 3 dB in your cable, what do you got left?
2.5.
If we use 6 dB, what do you got left? 1.25. 1.25. Yep. So yeah, because if you took your 5 watts, cut it in half, 3 dB, it's 2.5, right? And if you half it again, it's whatever half of 2.5 is, 1.25, right? It goes in half again. So the bottom line is you got to think about what's the application, So if you just randomly go, man, I always use 8X no matter what. Well, man, if you're operating on 2 meters and 440 and your antenna is more than 50 feet away, we know now that it's lossy. And it goes both ways. And then once you get to 213, LMR 400, that type of cable, that's about as good as you're going to get, at your ham station. Unless you go off the deep end and start buying stuff like this. Most of us don't. This is a scrap that a cell phone company guy gave me. And I think it's, don't quote me, but I think it's 5/8. Does that look like 5/8 to you guys?
Yep.
Yeah, this is 5/8 hardline. And you're welcome, after we get done, you can take your knife and you can pull this out. You can see the corrugated copper, which is a shield. You can cut this insulation, the dielectric off, and you can look at that center conductor that's bigger than a number 10 wire, I think. I think it's like a 9 or 8 or 9 or something. Thing's huge. And I think this one looks like it's aluminum covered with copper, and this outside is copper. You ever see those water heater hoses they're copper and they're kind of corrugated and they're kind of flexible? Flexible. Peel this back and it looks like a water hose, man. But it's 100% super duper copper shield. So this stuff, now look on your chart though, and look at your chart, and one of them will tell you, it's the second one, the second chart with all the more numbers on it. You can look at 1/2 inch, 5/8, 7/8 the hard line, the thicker stuff, and you'll notice that you really got to, at the higher frequencies, you really got to get the thick cable, the high quality cable to drop that loss. So when I talk to you guys and you're saying, well, and I don't want the person that is going to go, he's talking about me. Don't raise your hand. But we're talking about, I want to put my antenna pole over there because I can't see it. I'm going to run a conduit, or I'm going to put poles up. I'm going to do whatever it takes to get it. And you go, well, how far is it? Well, it's like 200 feet. Is 200 feet significant? Now, we got a couple of really, really seasoned radio dudes here. I'm just going to throw it out there. If you had an HF station that was operating between 3 megahertz and, let's say, 30 megahertz, and you're going to go over 200 feet away, what would you guys use? What else would you possibly consider using? Open feeder. And cheaper, and you put the open feeder and you'd measure it and you'd make it a 400 ohm or a 600 ohm, and you make your own little telephone poles and you run that sucker out there to your antenna, and it's very forgiving on the SWR. It's lower in loss, and it does a lot of cool things for you, but it's harder to work with. Oh, it's cheap too compared to that. If you're doing your UHF, VHF stuff, you can't do that. You got to buy something like this. So, thanks, guys. I hope that was okay. Go home and calculate your losses and come back next month and tell us what you got.